Hello friends, today we will start with Transmission Line Waveguides, Unit 1, Transmission Line Parameters and Theory. So first we will start with the introduction, and in this class today we will see what are the types of transmission lines. So coming to introduction, the electrical lines which are used to transmit the electric wave is called transmission line. So what is transmission line? The electrical lines which are used to transmit electric waves is called transmission lines. In short, TL. In short, TL. So example, like telephone messages, electric power signals. So these are traveled. These are sent in the electrical lines. So now let us start with the types. These are sent in the electrical lines. So now let us start with the types. Types of transmission lines. First is open wire line. Open wire line. It is a parallel conductors which is open to air. So the two cable wires that is separated by a air which is called as dielectric here, and these cables are mounted on towers or posts. So in day-to-day life we observe this. So our electricity cable transmission lines, so you can find which is coming to our home, we get the electricity. So it is a parallel conductor which is open to air. So this is open wire line cables. So open wire line, it is parallel conductors open to air. So this is first point which is open to air. Next point, it is separated by air as the dielectric. By air as the dielectric, and these cables it is mounted on posts or towers. So we have seen it looks like this. So it is having two conductors, So these two are conductors. This is, let it be conductor 1, conductor 2. So we have conductors which will carry the electric waves, and they are separated with some distance between these two cables. And it is air. This is dielectric, and air is the dielectric material between these two conductors. So let us discuss on disadvantages. First point, the initial cost is high. So initial cost is high. Next, as it is open to air, it is affected by wind, air, rainwater, ice and all. So it is affected by wind, air, water, etc. Next, the maintenance is very difficult. Maintenance is difficult. So we know during rainy season, power cut will occur, and due to the huge storm or the fall of the branches of the trees or some other sorts of things, so these cables are often affected. Next, there is possibility of shorting due to flying objects and birds. Possibility of shorting due to any objects and sometimes by birds. So these are the disadvantages. Next we will see second type, cables. So these are underground transmission lines. Example, telephone cables and electrical transmission cables. So let us discuss on telephone cables. So it nearly consists of hundreds of conductors. So this type of telephone cables, it consists of hundreds hundreds of hundreds of conductors which are insulated or covered, with papers. It's a special type of papers called oil impregnated paper or other solid dielectric material. Or any other dielectric material, and these 100 conductors are placed inside another protective lid, and these are placed inside protective lead, and both are considered as conductors. So let us assume this is the outer conductor, protective lead. So outer material, protective lead. So inside this we have nearly hundreds of conductors. So these are conductors which are insulated with any dielectric materials or papers. So each and every cable separated here. So the dielectric material could be any oil impregnated paper or any other dielectric, solid dielectric material. So this is the outer material, protective lead, inside which we have nearly hundreds of conductors, and each conductors are separated. Next example we see, that is electrical transmission cables. So second example is electrical transmission cable. It is similar to the previous type. It is also similar to telephone cables, but the thing is it has only two or three internal conductors. Okay, so the concept is same here. It contains two or three conductors which are insulated which are with papers, oil paper, or some other solid dielectric material, and it is placed in protective lead. So let us assume this is the outer protective lead. So inside this we have conductors. It contain either two or three conductors, and between this we have dielectric medium. So these two are conductors. Between these two conductors, the remaining areas, it is a dielectric material. Next type is coaxial line. So it contains two conductors. The first conductor is hollow, and the second conductor is thin solid conductor which is placed inside the first conductor, and it is uh, preferable for high voltage level. And between the two conductors, again we have a dielectric material, or the dielectric material can be a gaseous form also. So the dielectric may be any solid material or gaseous. So it contains two conductors, one is hollow. So the first conductor, which is the outer conductor here, the first conductor is the hollow conductor, and we have second conductor which is placed inside this hollow conductor, inside this hollow conductor. So this one is a outer conductor, conductor 1, and this is conductor 2. So between these two conductors we have dielectric materials or any gas format. Dielectric. Next type is waveguide. Waveguides. So this type is preferable for microwave frequency signals, waveguides, and it is for microwave frequency signals. So it is a hollow conducting tubes. It is a hollow conducting tubes through which energy is transmitted from the inner walls of the tube. So we have two types, rectangular waveguides and circular waveguides. So it is a hollow conducting tubes. Next point, here the energy what we transmit, it is transmitted from inner walls. Energy or the signal or electric wave is transmitted from inner walls of the tube. And another important point here is it follows internal reflection phenomena. So the energy which is transmitted, it follow the phenomenon of total internal reflection. So let us see how the rectangular waveguides looks. So the shape is rectangle and it is a hollow tube. It is a single conductor which is hollow. So the energy what we send inside, that energy will hit the internal walls and it travels. and it travels inside. So this is rectangular waveguide. And we can have circular waveguides also. So the shape is circular. It is a hollow waveguide, and these also follow the same phenomenon of total internal reflection of the signal.